Hi guys! So, do you ever look up at the night sky and start to wonder what else is out there? I can assure you that I did many years back, and I've been a massive fan of astronomy ever since, and I like studying it in my free time. One of the first questions that I ever had is, are we alone in the universe? Well, we can't be certain that we are, but we can definitely be certain that there are other solar systems and other planets out there. And when I say other, I actually mean about 4,200 planets in about 3,100 solar systems. That is massive, considering we only have 8 other planets in our own solar system. So let me introduce you to the concept of extrasolar planets, or for short, exoplanets. To start off, let me give you a quick rundown of what an exoplanet actually is and how and why we would ever expect to find life on one. Secondly, I'd like to go over 2 distinct examples of different types of exoplanets out there, distinctively Kepler 452b and Gliese 581c. Thirdly, I'd like to sum up the main and major issue when trying to locate and observe possible life in the universe. The space-time problem. If you have any questions, feel free to leave them down in the bar. So, for starters, an exoplanet can simply be defined as a planet orbiting a star outside of our own solar system. These planets can vary in size, some being smaller than Mercury, while others are even bigger than Jupiter. They also orbit around nearly every variety of star type there is. They can orbit in a star system just like ours with a relatively small yellow sun, or they can orbit around a cold reddish dwarf star, which is a really old type of star. Some even orbit around a binary star system, meaning 2 stars next to each other, making it seem like a scene straight out of Star Wars. There are 2 types of exoplanets out there: bigger, gassy and Jupiter-like planets called super-Jupiters, and smaller, rocky and Earth-like planets called super-Earths. But why are astronomers so interested in locating different types of exoplanets? Well, as I told you in the beginning, the number of exoplanets found each year is steadily increasing right now. We've already located well over 4,000 types of exoplanets. The ones that astronomers are particularly interested in finding are the ones that could potentially carry life and be inhabitable. These life-supporting planets must fulfill one very important requirement: they must be within their star's habitable zone. This habitable zone can be seen as the green zone around a star. It is the one that supports a planet's atmosphere, possibly consisting of breathable air. It also supports liquid water, and the planet's temperature won't be too cool or too hot. These are the 3 components that offer the perfect breeding ground to develop and support life, just as it did here on Earth. I've broken it down quite a bit, but that's the gist of it. So now that I've gone over the magical formula to create life, I'd like to introduce you to 2 distinct examples of exoplanets that were found throughout the last years, which are both within their star's habitable zone, but ultimately are very different from one another. The first one is called Kepler 452b. Well, sadly, all the cool names that refer to Roman gods have already been used up in our own solar system. You can see a concept art of Kepler in the thumbnail if you go back. This exoplanet is astoundingly similar to Earth, in that it also orbits its star in about 385 days, lies within the habitable zone, and supports liquid water. Sadly, this water is mostly toxic, and observations have concluded that this planet would probably not be able to support and sustain any life forms. The second planet I'd like to go over, which you can also see in the thumbnail, is called Gliese 581c. Again, weird naming conventions. This is a very interesting planet to look at because it actually orbits a red dwarf star, meaning a really small red star that is a lot cooler than our own parent star. Because of that, Gliese has to orbit its star very closely in order to be in its habitable zone at all. In this case, very closely means that 1 year on Gliese only consists of about 13 days. 13, that's not even a fortnight. This planet was also found at around 20 light years away, which translates to roughly 193 billion kilometers. That is way too far for us to ever reach. But as promising as this discovery might sound on paper, their distance brings me to my third main point I'd like to discuss with you today, and that is the biggest problem in the search for life in the universe: space-time. The concept that you must get behind is that in order for us to see an object in the sky, its light first has to reach our eyes. We can only perceive images through the light that they transmitted. Is that clear? The smaller the distance between two objects, the less time light needs to travel between them. To give you an idea of how much distance there must be between an object and our eyes in order for us to notice a delay, I'd like you to take a look outside your window. Somewhere out there you can probably see the sun. But you don't actually see it in real time. You rather see an image of what the sun looked like 8 minutes ago, because the sun is 8 light minutes away from Earth. Meaning that the light the sun emitted 8 minutes ago has just now reached our eyes. To give you an example of what I just talked about, but on a larger scale, I want you to realize that if somebody would currently observe the Earth from the other side of the Milky Way, they would most likely see dinosaurs walking around instead of students and people sitting in front of their laptops. That is just how long the light takes to travel all that distance. Can you follow me so far? So, to go back to the mind-crushing paradox that surrounds astronomy and observation of the night sky, you can probably guess what the consequences for the search for life out there are. The further we look back into the depths of the universe, the further we go back in time. There's just no way for us to get around that delay at all. When we observe an exoplanet that is 1,000 light years away, we practically see it through the eyes of people in the Middle Ages. We can never know for sure if a planet has already started developing life or if possible species have already died out, because the light will always take such a long time to reach us. If you just think about how much the face of the Earth has changed in just a couple hundred years, that seems to be a pretty soul-crushing realization. But you really should not worry. To conclude, I want to say the following. The fact that we are even able to locate and observe any planets out there is an amazing advancement in and of itself. It's something that our grandparents could only dream about. Astronomy and science are advancing day by day, and with each hour passing, more possible worlds are found. And with each hour passing, the light is moving a tiny bit closer towards us. You can be certain, with so many extrasolar planets out there and just so few criteria to kickstart life, it is close to impossible that we are alone out there. So, next time you look up at the night sky, just reach out your hand and wave. And maybe, in a couple hundred years, somebody might wave back. Thanks so much for listening to this video and to my presentation. I hope you learned something new today. And feel free to ask any questions in the comments down below. See you guys. Goodbye.